Welcome back, everyone. I'm really excited for this deep dive today because, well, we hear a lot about LLMs and ChatGPT and all of that, but honestly, I think encoder-only models are kind of the unsung heroes, powering so many of the tools we use every single day.
I think you're absolutely right.
Right. Like, think about it. Without encoders, we wouldn't have those supercharged search engines that can actually understand what we're looking for, or those spam filters that save our inboxes from, well, complete and utter chaos.
Yeah, no, absolutely. And I'm really intrigued by this paper we're looking at today. Smarter, Better, Faster, Longer. A modern bidirectional encoder for fast memory efficient and long context fine-tuning and inference by Warner and his colleagues.
What a title, really.
Yeah, it definitely grabs your attention.
Smarter, better, faster, longer. I mean, it sounds like they're describing the ultimate language model superhero.
Well, they might not be far off, actually.
Okay, so before we get too carried away, can you give us a quick overview of what exactly these encoder models are and why they're so important?
Sure. So in the simplest terms, an encoder model takes a chunk of text and turns it into a kind of numerical representation that captures its meaning.
So it's like translating language into a code that a computer can understand.
Exactly. And this code or this representation can then be used for all sorts of cool tasks like information retrieval, classification, you name it.
Okay, so when I type a question into Google and it actually finds websites that answer my question, that's an encoder model at work.
You got it.
And when my email filters out all those spam messages so I don't have to wade through them, that's another example.
Exactly. Encoders are working behind the scenes all the time, making our lives a little bit easier.
So they're kind of like the silent workhorses of the NLP world.
You could say that.
Now, the paper we're looking at today focuses on this new model called ModernBERT, and the title kind of gives away that it's supposed to be smarter, better, faster, longer.
Yeah, the authors make some pretty bold claims.
So what is it about ModernBERT that makes it so special? Is it just a souped-up version of BERT, or are we talking about something truly groundbreaking here?
It's definitely not just a minor upgrade. ModernBERT takes some of the most exciting advancements that we've seen in the world of LLMs and cleverly applies them to the encoder architecture.
Okay, so it's like taking the best features from the flashy sports car world and engineering them into a reliable, high-performance sedan.
Yeah, that's a great analogy. The result is a model that's not only powerful, but incredibly efficient, too.
I'm intrigued already, but hold on. Before we dive into the technical nitty-gritty, I want to make sure we're all on the same page here.
Yeah.
Why are these encoder models so important? I mean, we've talked about some everyday examples, but what's the big picture here? Why should we care about these advancements?
Well, think about the vast amount of information that's out there in the world. Text documents, code research papers, news articles, social media posts. It's an overwhelming amount of data, and it's constantly growing.
Yeah, it's like trying to drink from a fire hose.
Exactly. And encoders give us a way to make sense of all this information, to extract meaning, to find what we're looking for, to automate tasks, and ultimately to make better decisions.
Okay, so it's not just about building cool models. It's about using those models to solve real-world problems, to unlock the potential of all this data that's swirling around us.
Absolutely. And that's why advancements like ModernBERT are so exciting, because they're pushing the boundaries of what's possible. They're giving us new tools to navigate this ever-expanding sea of information.
So it's like we're getting a better map and a faster boat to explore this vast ocean of data.
I like that analogy.
Now, you mentioned that ModernBERT incorporates some of the latest advancements from the world of LLMs. Can you give us a taste of what those advancements are and how they're being applied here?
Sure. One of the key innovations that ModernBERT leverages is something called rotary positional embeddings, or ROPE for short.
ROPE sounds interesting. Tell me more.
Well, it's a way of encoding the position of words in a sentence, which is crucial for understanding the meaning of the text, especially when you're dealing with very long sequences.
So it's like giving the model a sense of order.
Yeah.
It knows that the cat sat on the mat is different from the mat sat on the cat, even though the words are the same.
Exactly. And traditional positional embeddings can struggle with very long sequences, but ROPE is much more robust and efficient. It allows ModernBERT to handle those longer stretches of text without getting lost.
Okay, so it's like giving the model a superpowered memory for keeping things in order.
Yeah, you could think of it that way.
That sounds incredibly useful for any task that involves long stretches of text, like summarizing a research paper or analyzing a legal document.
Absolutely, and it doesn't stop there. ModernBERT also incorporates other techniques inspired by recent LLM research, like prenormalization and GGLU activation functions.
Prenormalization, GGLU activation functions, that sounds a bit technical. Can you break it down for us? What are these things and why are they important?
Sure, so without getting too deep into the weeds, Think of pre-normalization as a way of smoothing out the flow of information through the model. It helps to stabilize the training process and prevent those vanishing gradients that can sometimes plague deep neural networks.
Okay, so it's like making sure the engine is running smoothly.
Exactly. And then GGLU is a type of activation function, which basically determines how neurons in the network are activated or fired up. It's been shown to be very effective in LLMs, and ModernBERT adapts it to the encoder architecture with impressive results.
So it's like fine-tuning the engine for optimal performance.
Yeah, that's a good way to put it.
So we've got a model that understands meaning, handles long text, and runs efficiently. What else is there?
Well, all these architectural improvements wouldn't be nearly as impressive without another key ingredient, the massive scale of ModernBERT's training.
Okay, we're talking about data, right? How much data are we talking about here?
A lot. We're talking about a model trained on 2 trillion tokens.
2 trillion tokens.
Yeah.
That's mind-boggling. Can you put that into perspective for us?
Imagine a data set containing every book in the Library of Congress, every article on Wikipedia, and a huge chunk of the internet's text.
Wow, that's a data feast.
It's a massive undertaking, and it's one of the things that sets ModernBERT apart from previous encoder models.
So it's not just about the architecture. It's about feeding that architecture with an incredible amount of diverse information.
Exactly. And this massive training data allows ModernBERT to develop a much deeper understanding of language and code, which is reflected in its impressive performance on a variety of benchmarks.
Okay, so they built this incredible model, trained it on an unbelievable amount of data. But I imagine training a model on that scale must have come with its own set of challenges, right?
Oh, absolutely. You're not wrong. They're training a model of this magnitude is no walk in the park.
So what were some of the hurdles they had to overcome?
Well, for one thing, they had to make sure that the data was genuinely shuffled randomly. You don't want to end up with predictable patterns in your training data that could bias the model.
It's like shuffling a deck of cards. You don't want to end up with all the hearts together.
Exactly. They also had to carefully tune the hyperparameters of the model, which control things like the learning rate and the batch size.
So it's like finding the perfect settings on a complex machine.
Yeah, and even with all the careful planning, they still ran into some unexpected roadblocks. They actually had to restart the training of their large model midway through because the initial settings were too aggressive.
So they had to go back to the drawing board and tweak things a bit.
Yeah, it's a testament to the complexity of working with these cutting-edge models, but the challenges they overcame make the results all the more impressive.
Well, it sounds like they had quite the adventure getting this model trained, but the real question is, how well does ModernBERT actually perform?
That's where things get really exciting. The paper details rigorous evaluations on a variety of benchmarks, and the results are, to put it mildly, impressive.
Okay, spill the tea. What kind of benchmarks did they use, and how did ModernBERT stack up against the competition?
They tested ModernBERT on everything from the GLUE benchmark, which evaluates natural language understanding, to specialized tests for long context retrieval and even code retrieval.
Code retrieval. So this model can understand and work with code as well as natural language.
That's right. Remember that massive data set we talked about? Well, it included a significant amount of code, which means ModernBERT has developed an impressive ability to understand programming languages.
That's amazing. What are the implications of that?
Well, it opens up all sorts of possibilities for applications in code analysis generation and even debugging. Imagine a coding assistant that can not only autocomplete your code, but actually help you write better, more efficient code.
That sounds like a developer's dream.
It could be a game changer for the software industry and beyond.
So we've got a model that understands natural language, and code excels at long context tasks and boasts impressive efficiency. What's the catch?
Well, no model is perfect, and the authors of the paper are transparent about some limitations. One notable point is that for now, their focus has been primarily on the English language.
So there's still room for improvement when it comes to multilingual capabilities.
Exactly, but even with that limitation, ModernBERT's achievements are a significant leap forward. It challenges assumptions about the capabilities of encoder models and opens up new possibilities for how we interact with information, automate tasks, and even push the boundaries of AI-assisted coding.
This is starting to sound like a true game changer, and I'm eager to delve deeper into its performance on those benchmarks. But we'll have to save that for the next part of our deep dive.
Sounds good. I'm looking forward to it.
Okay, so let's dive back into those benchmark results you mentioned. ModernBERT's performance was pretty impressive, right?
Oh yeah, definitely impressive is an understatement. In some cases, it's really groundbreaking.
Okay, so give us the highlights. What were some of the standout results that really caught your eye?
Well, one of the most striking findings was on the GLUE benchmark. That's kind of the gold standard for evaluating natural language understanding.
Right, GLUE, it's like the Olympics in NLP.
Exactly. And what's remarkable is that ModernBERT Bayes actually beat deBERT v3 Bayes on GLUE.
Wait, hold on, deBERT v3, isn't that a pretty strong model?
It is. It's a very strong model. It uses a different training method than ModernBERT, one that was considered to be superior in many ways.
So ModernBERT is not just performing well, it's actually challenging some of the assumptions about how these models should be trained.
Right, and that's what makes this result so significant. It suggests that with the right architecture and training data, the MLM approach, which is what ModernBERT uses, can be just as effective, if not more so, than other more complex methods.
That's pretty huge. I mean, it could have a real impact on how we think about developing encoder models in the future.
Absolutely, and it's not just GLUA. ModernBERT's performance on long context retrieval tasks was also exceptional. They used a benchmark called MLDR, which is specifically designed to test how well models can handle those lengthy documents we talked about earlier, like research papers or legal briefs.
And how did ModernBERT do?
It achieved state-of-the-art results, which is really impressive. It shows that this model can truly grapple with large amounts of information and still extract the most relevant insights.
So for tasks like research or summarization, ModernBERT would be a game changer.
Oh, absolutely. Imagine being able to quickly and accurately summarize a dense research paper, a lengthy legal document. That would save so much time and effort.
That would be incredible. And in the world of research and legal work, time is definitely money.
Exactly. And it's not just about time savings. ModernBERT's accuracy on these long context tasks means that you can be more confident in the results you're getting. You're not losing crucial information or misinterpreting the nuances of the text.
So it's about efficiency and reliability, a
Yeah.
powerful combination.
Absolutely. And, we've been focusing a lot on performance, but the paper also makes a big deal about efficiency. How does ModernBERT stack up against other models in terms of speed and resource usage?
Yeah, that's a good point. I mean, a model can be incredibly accurate, but if it takes forever to run or requires a supercomputer to operate, it's not going to be very practical for real-world applications.
Right, and that's where ModernBERT really shines. They ran a bunch of tests to measure inference speed, which is basically how quickly the model can process text and generate results.
And how did it do?
It consistently outpaced the competition, especially when it came to handling those long sequences that often trip up other encoder models.
So it's faster and more accurate.
Exactly. It's a winning combination. And
Yeah.
a lot of this efficiency comes down to those architectural innovations we talked about earlier, like the way ModernBERT handles padding tokens.
Padding tokens, remind me what those are again.
Sure, they're basically filler words that are used to make sentences fit a certain length for processing. Like if you have a batch of sentences and some are shorter than others, you add padding tokens to the shorter ones, so they're all the same length.
Okay. I remember now, and you're saying ModernBERT handles these padding tokens more efficiently.
Exactly. It uses a technique called unpadding, which basically eliminates those unnecessary tokens during processing.
So it's like decluttering your workspace so you can focus on the task at hand.
Yeah, that's a great way to put it. And this unpadding process saves a lot of computational power, which means ModernBERT can run faster and use less memory.
It's all about working smarter, not harder.
Right. And then there's flash attention, which is another technique that contributes to ModernBERT's impressive efficiency.
Flash attention, what's that all about?
It's a way of making the attention mechanism, which is kind of the heart of transformer models, much more efficient.
Okay, attention. That's a key concept in these models, right?
It is. It's what allows these models to focus on the most important parts of a sentence or a document, but it can also be computationally expensive, especially for long sequences.
So flash attention is like a turbocharged version of the attention mechanism.
Exactly. It's a way of speeding up the process without sacrificing accuracy.
And this all translates into real-world benefits, right?
Absolutely. ModernBERT can handle larger batches of data processed text faster and require less memory compared to other models.
So we're talking about a model that's not only powerful, but also practical. It can actually be deployed in real-world applications without breaking the bank or requiring a supercomputer.
Right, and that's what makes this research so exciting. It's not just about theoretical advancements, it's about developing models that can actually make a difference in the real world.
So what are some of the potential real-world applications of ModernBERT? Where could we see this technology making a tangible impact?
Well, the possibilities are pretty vast. I mean, anywhere you need to process and understand language or code, ModernBERT could potentially play a role.
Give us some concrete examples.
Sure. Well, let's start with search. Imagine a search engine that can truly understand the nuances of your query, no matter how complex or specific needing. ModernBERT's ability to grasp both meaning and long context could lead to search results that are far more relevant and accurate than anything we have today.
So no more wading through pages of irrelevant links, just laser-focused results that get right to the heart of what you're looking for.
Exactly. And it's not just about general web search. Think about specialized search applications in fields like law medicine or scientific research.
Where professionals need to quickly find the most relevant information from massive databases of complex documents.
Right. ModernBERT could help them sift through that information much more efficiently, saving them time and improving their decision-making.
So it's not just about making our everyday searches better. It's about potentially transforming how professionals access and utilize information in their fields.
Absolutely. And it's not just about retrieval either. Think about tasks like summarization. ModernBERT's ability to handle long documents means it could generate concise and accurate summaries of lengthy reports, research papers, or even entire books.
That would be a game changer for students, researchers, or anyone who needs to quickly grasp the key points of a complex document.
And let's not forget about the potential impact on code, as we discussed earlier. ModernBERT's training on a vast dataset of code has given it a remarkable ability to understand and work with programming languages.
So we could see more sophisticated code assistants that can actually help developers write better code, not just autocomplete it.
Exactly. Imagine a coding partner that can suggest improvements, identify potential errors, and even explain complex concepts.
It would be like having a senior developer looking over your shoulder, giving you real-time feedback and guidance.
And the applications go even further. ModernBERT's advancements could lead to more sophisticated and helpful chatbots and virtual assistants capable of understanding complex requests, providing personalized recommendations, and even engaging in more natural and engaging conversations.
It sounds like we're on the cusp of a new era in human-computer interaction, where our interactions with technology become more seamless, intuitive, and even, dare I say, enjoyable.
I think you're right. And one of the most exciting aspects of this research is that it's not just about a single model. It's about a new way of thinking about encoder architectures and training methods.
So it's not just a finished product. It's a foundation for future exploration and innovation in the field of encoder models.
Exactly. And the authors have actually introduced something called FlexBERT, which is a modular framework that allows researchers to easily experiment with and build upon ModernBERT's innovations.
So they're not just keeping their secrets to themselves, they're sharing their work with the community and encouraging further development.
Right. They've also made all of their intermediate training checkpoints publicly available, which is incredibly valuable for researchers. It allows them to study the model's evolution during training, understand how its performance changes over time, and potentially even adapt the training methodology for their own projects.
It's a fantastic example of open science in action, fostering collaboration and accelerating progress in the field.
And this spirit of openness is one of the things that makes me most optimistic about the future of NLP. By sharing knowledge, resources, and ideas, we can collectively push the boundaries of what's possible and create truly transformative technologies.
Now, I know we've been painting a pretty rosy picture of ModernBERT and its potential, but like with any new technology, there are always challenges and considerations that need to be addressed. What are some of the potential limitations or areas where further research is needed?
Well, one area we've already touched upon is the need to expand ModernBERT's capabilities beyond the English language. Developing truly multilingual versions of this model will be crucial for ensuring its wider accessibility and impact, especially in a world where information and communication transcend linguistic boundaries.
That's a really important point. It's not just about translating the model. It's about ensuring it can understand the nuances and complexities of different languages and cultures.
Exactly. And while ModernBERT has demonstrated remarkable efficiency, there's always room for improvement, particularly as we deal with increasingly massive data sets and complex tasks. Further research into optimizing these models for both performance and resource usage will be essential.
So finding that sweet spot between power and efficiency will be a key challenge for future research. What else should we be keeping an eye on?
Well, as these models become more sophisticated, we need to prioritize making them more transparent and interpretable. It's not enough for them to just work well. We need to be able to understand how they arrive at their decisions, especially if we're going to trust them with important tasks.
That's crucial, especially as we start to integrate these models into sensitive areas like healthcare, finance, or even legal decision-making. We need to be confident that they're making decisions based on sound reasoning and not just on spurious correlations or hidden biases in the data.
Absolutely. And this is where collaboration between computer scientists, ethicists, and domain experts becomes crucial. We need to develop frameworks and guidelines for ensuring that these powerful tools are used responsibly, ethically, and in a way that benefits society as a whole.
It's a reminder that while the technological advancements are incredibly exciting, we can't lose sight of the human element. We need to ensure that these tools are developed and deployed in a way that aligns with our values and serves our collective goals. You know, as we've been talking about ModernBERT and all of its capabilities, I can't help but think about the bigger picture. I mean, what does this all mean for the future of NLP? Where are we headed with all of these advancements?
Yeah, that's the million-dollar question, isn't it? And I honestly think the answer is both exciting and a little bit daunting.
Daunting, how so?
Well, on the one hand, we're seeing incredible progress in NLP, like the pace of innovation is just mind-blowing. New models, new techniques, new applications. It seems like there's something new every week.
Yeah, it's hard to keep up sometimes.
But on the other hand, we're still grappling with some fundamental questions about how to best harness this power, how to ensure that these advancements benefit humanity as a whole.
So it's like we're standing on the edge of a new frontier with all of its potential and all of its unknowns.
Exactly. And I think one of the keys to navigating this frontier successfully is recognizing that the future of NLP is not just about building bigger and better models, it's about understanding how those models fit into the larger ecosystem of human knowledge communication and creativity.
So it's not about replacing humans with machines, it's about augmenting our capabilities, empowering us to do things we never thought possible.
Precisely, think about a world where we can seamlessly interact with vast stores of information using natural language, where complex tasks can be automated with a few simple commands, where language barriers are a thing of the past.
Okay, now that sounds pretty utopian.
It does, but I truly believe that kind of future is within our reach, and models like ModernBERT are paving the way.
It's exciting to think about, but I also can't help but wonder about the potential downsides. Are there any risks or challenges that we need to be mindful of as we venture into this new landscape?
Oh, absolutely. I mean, like with any powerful technology, there's always the potential for misuse.
What kind of misuse are we talking about?
Well, for one thing, there's the risk of these models being used to spread misinformation or to create harmful content like deepfakes or propaganda.
That's a scary thought.
It is, and it's something we need to be very aware of as we develop these technologies. We need to build in safeguards and develop ethical guidelines to ensure that they're used for good, not for harm.
So it's not just about the technical advancements, it's about the ethical considerations as well.
Exactly. And then there's the issue of bias. These models are trained on massive amounts of data, and that data can reflect the biases that exist in society.
So if the data is biased, the model could perpetuate those biases.
Exactly, and that could lead to unfair or discriminatory outcomes, which is something we definitely want to avoid.
So how do we address that? How do we make sure these models are fair and unbiased?
It's a complex challenge, but there are a few things we can do. One is to be very careful about the data we use to train these models. We need to make sure it's as diverse and representative as possible.
So we need to be mindful of the data sources and the potential biases they might contain.
Right. And we also need to develop techniques for debiasing the models themselves, for identifying and mitigating any biases that might creep in during training.
So it's an ongoing process. We need to constantly be evaluating and refining these models to make sure they're aligned with our values.
Exactly. And that's why it's so important to have open and honest conversations about these issues to involve a diverse range of perspectives in shaping the development and deployment of these technologies.
It's a reminder that the future of NLP is not just about the technology itself. It's about the people who are creating it, using it, and being impacted by it.
Absolutely. And I think that's a good note to end on. The future of NLP is ultimately in our hands. It's up to us to ensure that these advancements are used to create a better, more equitable, and more just world.
I couldn't agree more. Well, this has been a fascinating deep dive. I feel like I've learned so much about ModernBERT and the future of encoder models.
It's been a pleasure discussing this with you.
And to our listeners out there, we hope you found this episode as insightful and thought-provoking as we did.
Keep exploring, keep learning, and keep asking questions, because the world of NLP is constantly evolving and there's always something new to discover.
Until next time, happy deep diving.